Hi everybody, I'm Scott Stanchfield and welcome to Android Development. Let's talk about some of the course logistics. I've been a developer since 1989. This is me, by the way. Yay! And I've been doing programming in Assembly 370, PL1, Pascal, several other languages. During that time, I was also working for a compiler company out in California, and I was on the ANSI C++ 98 committee for a couple meetings, and maybe someday I'll tell you the story about why design by committee is a really, really bad idea. But it was a neat experience. After that, I became a Java instructor, flying all over the world teaching Java to hapless victims and having a blast with it. After I settled down there, well, kind of more like after the venture capitalists decided they didn't want a training company, they wanted a .com 3 months before the bust, I started doing some teaching. So I moved back out to this area, and for those of you who are watching this from remotely, this area is the Washington, D.C. area. And I worked for Montgomery College in Montgomery County for 2 years, training people to go from non-programmer jobs to programmer jobs. That was kind of fun. A couple years into that, I got my foot in the door at Johns Hopkins University and was able to start teaching classes here. The main classes that I worked on were design patterns and this Android class. Here's some pictures of me. This one in particular is me climbing in the trees at the Sandy Spring Adventure Park. If you're in this area, Sandy Spring, Maryland, there's this wonderful ropes course park. It's got, I think, about 16 different courses right now, and most of them have a couple zip lines in them. All sorts of varying levels. So much fun. This is me swing dancing, one of my big hobbies. I really miss it during the whole pandemic because you get a lot of close contact with it, but it was just a blast dancing around, and it's also great exercise. This is one of my other fun hobbies, riding roller coasters. This is the Dominator down at Kings Dominion in Doswell, Virginia, just north of Richmond. And this particular picture I just love because they put a camera right at this one spot where this wind gust always hits you. And so everybody just looks like they're completely blown away. And it's really just our faces are full of wind and we can't keep them open. But great ride down there. And this is me at a different amusement park, Cedar Point in Sandusky, Ohio, back when I was a kid. And I was in a bear costume. I was Brother Berenstain Bear with a really, really horrible mustache, which fortunately nobody had to look at. I've worked for some famous people along the way, and I really like to name drop, so I'm going to call them out. If you've heard of the term cyclomatic complexity, which is a linear algebra method of trying to determine the complexity of software, it was invented by a guy named Tom McCabe. And he has a company in Columbia, Maryland, and I worked for him for a few years. And he is a guy who's a pure mathematician. So he thought linear algebra completely explained programs, but didn't take into account data heuristics. So I was talking with him about this many times, and it was kind of a headbutting competition because I think we really needed to add some knowledge into our tools about how the data is moved around and what changes. If there's no data in a program, yeah, I think cyclomatic complexity would really describe things wonderfully. It's actually a decent measure, but he was using it to try to drive what test cases you should run. And with test cases, data is a huge, huge deal. Now, after working there, I moved out to California and worked for Frank DeReamer and Tom Pinello. These are the two folks who invented LALR parsing. This is the parsing technique behind Lex and Yak, and it's used in many, many compilers. The front end of a compiler has to read in some source code and figure out what it means. And that reading in and figuring it out has to have some kind of a parser. LALR parsing is one of the main components of it, but there's also another type of parser called LL parsing, and that was one which is used by the tool called Antler, ANTLR, which was developed by Terence Parr. And I'm personally much more of a fan of LL parsing because there's some things you can do with it that you can't do in LALR parsing. That's one of the reasons why I got into the compiler company, was because they were looking for some LL people to work on some new things in the C++ that was being updated in 98. When I worked for Terence Parr, I was flying around teaching Java. That was what his company was. But he's the guy who created PCCTS, the Purdue Compiler Construction Toolset, and Antler. So if you've heard of those tools, if you look up Antler 2.0, my name's in the documentation. Yay! Because I did some work on the tool itself. I'd like to ask everybody if you can please make sure your contact information in SIS is up to date. Your email and your phone number really need to be correct in case I need to communicate with you. You get all the announcements that come from the course. Anytime I add them into Blackboard, you're going to get that through your email. So please make sure that's up to date. Make sure you read the entire syllabus carefully. It's kind of lengthy, and it goes into a lot more detail than we have here. It also includes a lot of policies from the university, including the academic integrity policy. It goes into my grading scheme and how projects are graded and things like that in much more detail. So please take a look at that. I'm going to cover it pretty briefly in this talk, but you're responsible for anything that's actually in the syllabus as well. The course site is actually now a GitLab repository. I've actually moved all the content into there, and you can download that. The videos are going to be hosted on YouTube, but the content for this course, all of the sample code and the course outline and so on, are at the GitLab repository. So make sure you look there. The main page includes the outline for the course, which modules we're covering each week, what assignments are due when, and so on. Let's talk about grading. Your grade in this course is going to be based on 6 programming assignments. Each of them will be graded A through F with a plus or minus on them. There is no A plus, by the way. That's caused some issues in the past where people would assume that if they didn't have the total number of points that were available, which included an A plus, then they were losing points. And A plus was really intended more of when somebody does something kind of exceptional, we'd give it to them. So it was very rare, and we wanted to leave some room for it. But that ended up causing some ruffled feathers here and there. So we decided to get rid of that, and the highest grade will just be an A. We will, when we grade the assignments, give you a bunch of comments. We will not include point deductions with those comments. It's just going to be a group of comments, and then we're going to give you a letter of grade based on that group of comments. The reason for this is that over the years, people would constantly complain about 1 point here and 1 point there, and it really never made any difference. To really go into this philosophy I have called holistic grading a little bit more, take a look at the syllabus. But the main idea is we just like to look at the assignment as a whole and decide what it's worth as opposed to different points here and there. And using rubrics and things like that always cause problems. People would either game the system, or sometimes their grade would come down because the rubric said X, Y, and Z are all worth a point each. And if they did too many of those, the grade comes down a lot farther. So we have a lot of things we like to do, like there's certain items that we throw into an A minus bucket. So it's like if you do certain things, we just say, okay, that collection of things maxes your grade as an A minus. Other types of things, when we look at it, it'll bring your grade down further. But we didn't want you to have, death by 1,000 paper cuts from silly little things. When you're turning your assignment in, each day late is a full letter grade deduction. What we really want to try to do here is get everybody to turn things on time so that if people want to talk about assignments at office hours, for example, or if I'm teaching this class live, if you want to talk about the assignment in the next class, we can do so. If people are turning in assignments late, I can't get into the details. Your final grade in the class will be A through F, as well as incomplete as an option, without a plus or minus. And we started doing the plus and minus when we first offered it. The problem was that a lot of people's companies are paying for them to come here, and the companies didn't know what to do with the pluses or minuses as far as reimbursement. In addition, the final grade and the GPA that you get from Hopkins only counts on the full points. So any of the A's, whether it's a plus minus or a normal A, is worth 4. Any of the B's is worth a 3, and so on. So to help simplify that, we decided to go without the plus or minus. I do not curve in this class, so it's possible for everybody to get an A. It's possible for everybody to get a B. I mean, it just depends on how you do in the class based on your own work and not compared to other people's work in the class. So some general grade guideline information, and I'm going to say a little note about this. Don't look at this and say, well, I couldn't have had a B because I didn't do one of these things. These are just some generalized ideas of why you might have gotten a B or a C or an F or an A. With an A, it generally means it was on time, it was working, and you did a good job on the design. With a B, maybe some things weren't quite working, or maybe there's functionality that was missing, or it was a bad design, bad style, or it was a day late, but otherwise would have been an A. With a C, the types of stuff that'll usually drive you down here are lots of problems. If you started your assignment super late and just couldn't get things done, if it doesn't compile or doesn't execute properly, or lateness from A and B can bump you down here. For an F, usually you have to try pretty hard to get this, or you don't try at all in the assignment. Sometimes people basically copy the sample code, put their package name on it, and turn it in. If we see that kind of a submission, that's going to drive you into F territory because you're really not doing any work on it. We want to make sure that you do an effort toward the assignment. If you do well on the assignment and do all the functionality, that's where you get your A. If you don't put any effort in, you're going to get an F. Also, if you end up plagiarizing or if you work together on the actual code for an assignment, that can throw you in an F. And we're really good at catching this, so please don't work together on things. Unfortunately, I've caught several people over the years doing this, and it's some of them we've actually had to go to the academic integrity hearings on it. Most of the time, yet we end up doing an informal resolution on it, which can end up driving your grade down pretty quickly. Don't do it. Submit work that's your own. I'm going to talk about plagiarism in a little bit more in a minute. Or if you just plain don't turn something in, that's going to be an F. And depending on what's going on, if there's some kind of an issue, if you're having a really tough work time, or if you have like a severe illness, talk to me about it. We can work something out. Sometimes I'll give an incomplete. So if there was some kind of circumstances come up, like every once in a while somebody's company might say, hey, we need you to send you overseas for 3 months. And obviously that's going to impact your course. And if you can't get the work done, we can work on that. We can do an incomplete or figure something else out. As far as academic integrity is concerned, the big thing here is all work must be your own. The work that if you find something you want to copy from somewhere, you just got to make sure you attribute it. And the idea here is that whatever you're presenting to me, you're saying you did it, unless there's an attribution on there, and the attribution says, I got this from somewhere else. If you found something on a course on a website somewhere, and the website says that you can use it, so it has some kind of licensing information, you can copy it and put an attribution in there, and that's perfectly fine. But most of the work should be your own. And it's come to my attention that some people have decided, well, it doesn't matter how I taught the class, I'm going to do things based on some article I found online. Don't do that. I expect that you're going to follow the techniques that I show you in this class. So when I tell you do things a certain way, that's what we expect to see in your assignment. We don't want you to say, oh, okay, the assignment is this type of an application. I'm going to go online and find how to do that application and do it completely differently. Don't do that. Your grade will suffer. As far as working together, anything that we talk about in the lectures or the assignment descriptions itself, you can discuss amongst each other. So if you think you need clarification, you can ask each other, you can ask on the forums, you can ask me, and that's perfectly fine. But when it comes down to actually writing code and structuring your project and figuring out what pieces you put together, no, you can't do that unless there's some kind of group assignment. Right now, I don't have any group assignments in the class, but that could change. At some point, I may add one. Now, if you end up violating the academic integrity policies, you're going to get a 0 at least on that assignment. I had someone a few terms ago who basically the first 5 assignments turned in somebody else's work from a previous term. And that ended up going to a hearing because he wouldn't accept the informal resolution we wanted to do. And there were some pretty severe penalties on that, including suspension, as well as getting a notation on his transcript saying that he had cheated in the class. So the university takes this very, very seriously. Most of the time, the first time it happens, it's just a 0 on assignment, and you get a note in your file. If it happens a second time, you're going to fail a course and potentially get kicked out of the program. But again, it depends on how serious the infraction is. In that particular example, the infraction was really, really just egregious. And as well as there were some issues with the student's communication to me about it where he made some threats. Don't do it. Just make sure that everything you turn in is your work and attributed for anything that isn't your work. Now, this also doesn't just count for final submissions. I had one student a few terms ago turned in some code to me to ask a question. So it was before the assignment was due. And he asked, why isn't this working? And I looked at the code and I recognized it as an example from online. And it looked like he was basically taking some example code and trying to just submit that as though it was his assignment. No attribution or anything. And I called him on it, and he's like, well, it's not the final submission. It doesn't count. I was going to redo it. And no, anytime you hand me code, if the code is, if you're handing me code saying that this is your code, it better be your code. Otherwise, you are misrepresenting it and you're plagiarizing. For code attribution, so keep in mind, again, most of the code in your assignment should be code you've written or come from class examples. There's going to be some assignments that will look very similar to a class example. There'll be other ones where you have to take pieces from different examples and merge them together and figure out how to use them. That'll be most of the thing. But if you find a little snippet online that you really want to use, feel free. But you have to make sure that it has a license. So on the website, there should be something there telling you how it's licensed. If you find it in a repository online, if that repository has a license file in there and describes a license that's non-viral, sure, you can use that. Don't use any licenses that are viral. So GPL, the Creative Commons Attribution Share Alike, that's CC by SA, those ones are viral. And what that means is if you use that, you have to license your code the same way that the source code was originally licensed. You need to attribute any code you're copying in at the point of use. So here's an example at the bottom. Just a little comment saying where you got it, so some URL, the license that it is, so just jot the license down, and then your block of code. And then put a little comment at the end saying this is the end of the copied code. That's all you need to do. I want to give everybody a caution about Stack Overflow, though. For this class, it's perfectly fine if you find little snippets on Stack Overflow. And Stack Overflow is a fantastic resource. But in real life, there's a huge, huge problem with it. They've licensed the content. Anything that you write on Stack Overflow or any answers you see on there, everything there is licensed Creative Commons with attribution, share alike. That's the CC by SA license. This is a viral license, and it's really critical that you don't copy snippets from Stack Overflow and put it into your code at work or your personal code, because then, unless you're licensing your code CC by SA, you are breaking the license. And that could result in lawsuits. It could result in any old thing. Most companies are not going to want you to do that. Any type of government work is not going to want you to use that type of license. So to fix this, what you need to do is when you look at Stack Overflow, read it, understand what you're trying to get from it, and then close the web page. It's really that simple. If you just get the concept from there, you're fine. The problem comes when you're actually copying blocks of code. Now, if you're somebody who's really good at memorizing blocks of code, don't do that. Make sure that you're understanding the concept behind it, and then you write your own code to implement that concept. It can end up looking the same in the end, but you don't want to copy it. You don't want to try to remember, oh, here's exactly what those lines look like. So use a clean room approach and you'll be okay there. Now, as far as the kind of buckets of information in the grades, there's really 4 areas I look at: design, function, style, and timeliness. As far as design is concerned, are you using the patterns I discussed in class? So it's really important here. Do things the way I'm telling you to. There's a reason for that. There's a reason I'm teaching the class. I'm trying to get across some practices that I think are good ways to develop some Android code. Now keep in mind, that can change really quickly. Android is a very fast-moving target, and other people come up with better ways to do things all the time. I'm just trying to give you the best practices that I've encountered in my development and from what I've seen online as well. So I've been doing a lot of research on it. I've been doing a lot of programming, and I want to demonstrate these techniques to you. Make sure you use any type of abstractions that I tell you about as well. So if I'm telling you to break code out into a view model, make sure you use a view model for it. Does the design fit the problem? Or are you, hammering a square peg into a round hole? As far as function is concerned, does it work? I mean, one of the things that we want is, that the function you submit actually works and doesn't crash, does what it's designed to do. And is all of the required function present? And I mean all the function. If there's things listed in the assignment description, you need to do those. You can't pick and choose which things you want to just submit. That's not sufficient. And missing function will drive you down into B territory very, very quickly. As far as style and coding conventions, can we read the code? and just figure out what it does by reading it. Did you follow the coding conventions I'm going to talk about in a minute here? And then timeliness, was it submitted on time? Again, one letter off for each day late. As far as your assignments, writing the assignments, all of your assignments must be written in Kotlin. There's a Kotlin primer that's included with this course where I'll just kind of go over the basics of the language. But for the most part, you're going to learn Kotlin by osmosis during the class. Or if you want to do some study on your own on the side, that's perfectly fine. Or you can take my Kotlin class that I teach for Hopkins. I do assume that you're very comfortable with Java. I don't assume that anyone knows Kotlin coming into this course. So anytime you have questions on the language, feel free to ask on the forums. I'll answer or somebody else will answer. You'll learn the language pretty well during this class. The Kotlin class that I teach here at Hopkins goes into a lot more detail, but you're not going to need that level of detail for this class. All of your assignments must be built using the Gradle build system and in Android Studio. So don't try to use Emacs to do your assignments. First of all, I think it's a horrible, horrible idea. I know some people absolutely love other IDEs, but Android Studio has a lot of assistance in there for making sure that your program is going to work right. As well as when we look at it, it's going to be a lot easier for us to bring your projects up and evaluate them. You can turn in your assignments any number of times that you would like, but we will only grade the last submission. Please don't ask us to say, oh, well, can you give us the grade that's better on these two? Sometimes, people might turn in something on time and then turn in another copy of it late and then say, well, based on which one's going to be the better grade, can give it. Nope, we will just grade the last submission. Coding conventions. So why do we need these? Well, we read your code. And the thing that's really important there is we want to make sure that we understand what you're writing, because when you turn it into us, there might be some problems. And you might be turning it into us while you're still working on it, asking questions. If we can't read it, we're not going to be able to help as well. It's going to take quite a bit more time. Also, if we can read the code and there were some problems when you submitted it, we like to try to tweak it to see what happens to make it work. Sometimes it's just something really simple, like a little Boolean Boolean condition reverse somewhere. And if your code's readable, we can do that. We can tweak it and then hopefully give you better partial credit on that. Now, keep in mind, we do this on several assignments. So, when we have lots of submissions coming in and we've got to try to get the grades out fast, if we can't read the code, that really slows things down for everybody. And it takes longer to get the submissions back. So the coding conventions that we would like to ask you to use. For leading indentation, spaces or tabs, but don't use both. Pick one and stick with it. And that way, when we look at the code, we'll see what you're seeing. When you have types or composable functions, these should be upper camel case. Now, composable functions will make sense a little bit down the line when we start talking about Jetpack Compose. But there's a special type of function that represents a definition of part of your user interface. And because of that, they're trying to make it seem more like an object than a function call. So they want to treat that like an object with upper camel case as well. So types, we're talking about object names, class names, interface names, enumeration names, sealed classes, sealed interfaces, any of those types of types, those are all going to be upper camel case. Now, pretty much everything else, variables, normal functions, things like that, are going to be lower camel case, like these examples on the screen here. Your names of things should be full words. Don't use random abbreviations or single letters. If we see something like BCNT, where you're trying to say button count or something like that, it's not going to mean anything to us. And putting a comment there isn't going to help, because then we're going to have to try to remember BCNT was button count everywhere. Spell it out, button count, as a lower camel case, for example. Now, if there's a standard acronym like URL that's super, super common, feel free to use that. That's perfectly fine. As well as some of these exceptions down here, like integer counters in a loop, I, J, and K, perfectly fine. If you have the current number of something, you can use N. If you're a exception in a catch block, use E. Those are all perfectly fine. As far as names of the top level things, so your project name is going to be HW1, HW2, and so on, all uppercase. The name of the file that you submit to us should be your last name, first name, and then HW123, whatever, all lowercase. Your application ID will be the same as that. And the application ID is what makes your application unique if you were to publish it to the Google Play Store. Once somebody publishes that with a signature to the Google Play Store, nobody else can use that name, so you're guaranteed uniqueness. All of your package names, where you put your actual code, have to start with that same scheme, last name, first name, HW123. You can have everything in a single package, or you can have any number of packages you want. Use the packages for whatever organization you would like, but keep in mind it's perfectly acceptable to have everything in one package. Here's some examples here where I might have Stanchfield Scott HW4, Stanchfield Scott HW4 model, Stanchfield Scott HW4 database as some of the packages in the application. All of your user-facing strings must be externalized into your strings.xml. And what I mean by user-facing strings, if the user sees something on the user interface, so on the screen, that's considered a user-facing string. If it's data, so it's something the user typed in and you put in a database, or maybe you had some pre-populated stuff in a database, that doesn't have to go into your strings.xml, and doesn't make sense to go in the strings.xml. It's just a list of any type of string literals you might have. The reason that we do this is so that you can localize your application for different languages or different regions. And it's real easy to override these strings.xml files for different areas to provide that localization. Now this means all, so any string the user might see must be externalized. As far as discussion participation, first of all, there is no required written discussion online. I know students generally hate that. I did that for a couple terms, and the main objection I have to it is that it's extra work. So if you took the class online, you're having to do more work than you would have done in a face-to-face class, and I really don't feel comfortable with that. I like it to be the same workload no matter when you're taking the class. The summer session is normally the face-to-face session, and it's compressed a little bit more, but it's still, you're just doing the assignments. You're not doing some extra work for discussions. And personally, I don't really think that the discussion forums gives the student interaction that they're trying to look for. That was their main reason they wanted them. They want to try to get the students to interact more, and I don't think the discussion forums really worked well for that. If you have any questions, feel free to ask them at any time. Now, if this is a face-to-face class, obviously that makes it's you can just interrupt me whenever to ask a question. When it's a online class, you need to communicate somehow to me, and I ask that you use the discussion forums first, whether it's the general discussion forums or the ones that are specific for assignments. What that does is I monitor those, and if I see it, I'm going to answer it, but I might not be able to get to it right away. Depends on what's going on. Somebody else might be able to answer it right away. So you might get a faster response that way. I will get to it within 24 to 48 hours. But the other big advantage here is that if other people have the same questions, they'll see the response. Or maybe somebody didn't even think to ask the question, they can still see that response. So the discussion forums, use those first, please. Unless it's something private. So if it's grade related or if there's a personal issue, please send me an email at scottstanchfield@jhu.edu. You can make comments about things at any time, suggest alternatives, and give me some course feedback. So at any point, if you're seeing something that, there's problems with the way the course material is organized, or if you think there's a better way to do something, feel free. I'm happy to. And I don't necessarily mean just in the structure of the course, but if there's a piece of code that you look at that I've written and you think there's a better way to write it, please suggest it. Sometimes, when I'm writing these examples, they can get kind of long and I might be a little tired. Or when I'm recording the video and writing the code in front of you, something might not go ideally during it. Now, office hours, these are for online classes only. It's going to be one 1-hour session per week, and that will be available via a link on the Blackboard site. So if you go to Blackboard, over on the left edge, there's a link for the office hours, and it'll tell you when that is as well. There'll be one 1-hour session per week. If nobody shows up after 20 minutes, I just close it. Unless somebody sent me an email saying, hey, I'm going to be half an hour late. Can you please keep the office hours open? That's fine. We're going to be using Zoom for this. If you have any questions about Zoom, please take a look at the syllabus. There's some information in there on how to set it up.